Okay. What's up? I think I got everything set up. Think I'm good to go. If you do sub, you get the Wahoo emote. There's the Wahoo emote in the chat. Let's jump straight into it. It is 4:25. We're gonna do Geo notes first. I'm streaming for both Algebra 2 and for got an emote thanks to Shamel's subscription. Thank you. The subscription. Nice. Oh, there's the you also got the first icon by your name. That's awesome. I don't know why, but the sound is coming out of my speaker and not my headphones. Not sure why that is. But it is what it is, I guess. All right, so I'm streaming for both Algebra 2 and for geometry. So if you are in Algebra 2, I'm doing geometry first. I don't know if you're tuning into the stream as a Algebra 2 student, but I am doing geometry first. So these are the notes right here. This is the PDF. All right. So we're going to quickly run through these. The lesson 1 is basic terms of geometry. So just some pretty quick definitions on the first page that I think most of us are going to be familiar with. Okay. So I guess I'll look at my iPad down here. It's kind of a weird sensation here to be doing all of this at once, but a point is a specific location. It has no dimension and it is represented by a single dot. How easy is that? Let's do purple. Here's my single dot. It's point P, right? Easy as that. Hello. The hype train's at 94%. An endpoint is a point at either end of a line segment or starting point of array. So it's a point that ends a segment. Here's a segment that has a clear beginning and end. Or here's a ray which goes off in a single direction, which I'm about to define below. A line segment. So there's lots of people confuse the words line and line segment. A line is something that has no beginning or end. It's infinite. It goes off in both directions. Whereas a line segment is something that has a clear beginning and end. So it has maybe a endpoint C and D, whereas a line has no beginning or end. It just goes off infinitely. All right. What is that notification that repeatedly keeps going off? Oh, that's the following one. Okay, that's fine with me. It's very insane to see all the notifications on my end. I haven't had this much activity on the channel before, so it's hard keeping up. So let me restart a little bit, right? We have a point. That's the most basic thing. Endpoints are these beginnings and ends, and with points we begin to construct objects in geometry. If you connect a couple of points and you go off infinitely, you have a line. If you connect a couple of points but it's a clear beginning and end, you have a line segment. And you can notice the difference over here. A line, if I zoom in, has double arrows, right, over the top. That means it's a line. Whereas if it's a single bar over the top, that means it's a segment, right? You have to connect 2 points to make a segment or a line. It takes 2 points, A and B, C and D, but the difference is a line is infinite where a segment has a clear beginning and end. Um, a ray, as I already drew up here in this picture for an endpoint, is something that has a clear beginning but then goes off forever in one direction. Okay. And the way we name rays is actually something super specific. We always name the ray with the endpoint first. You see that? That's ray GH. We could not refer to this ray as, I don't really need a circle. We would not refer to this ray as HG. That's wrong. Okay? Because it starts with the letter G and then goes off towards H. Hopefully that makes sense. There is lots of activity in the chat. Well, at least on my end, I'm seeing a lot of messages. But if we do ever have a question, you can always ask, and I will try to answer it. What else here? When it comes to naming over here on the right, you can see that we were able to exchange the letters A, B, B, A. We're referring to the same line. It doesn't matter what order you do it, right? It doesn't matter. Same with the segment. You can refer to it as CD or DC. The order doesn't matter. For a ray, order matters. And naming objects is a pretty big deal in geometry. Being able to speak about the objects that are on the page is a pretty big part of geometry. So we need to be able to name things correctly. So I'm drawing on this piece of paper, my iPad. What is this piece of paper, this flat object that I'm writing on? All of these segments and lines and rays exist on this piece of paper, and this piece of paper can be referred to as a plane. Are we supposed to be taking notes? That would be ideal that you do that. Print out the notes and follow along. Open them up on your iPad, follow along. The notes are in Canvas, so you can have these exact notes if you'd like. My friend is calling me, but I won't answer right now. Um, so a plane is a flat two-dimensional surface that extends infinitely far. So here's this two-dimensional surface, right? And then I can place objects on this surface, right? I can put a segment on the surface, right? A piece of paper is a plane, right? So it's this plane that everything exists on. I'm kind of doing chores, but I'm watching still. Perfect. Collinear points. Let's kind of dissect that. What does it mean to be linear? That means in a line, in a straight row, right? So what would be an example of collinear points would be these 1, 2, 3 points. They are points that lie together on the same line. All three of those points are on the same line. But if we were to draw 1, 2, 3 points not in a row, right? There's no way that I can connect all three of these points with a straight line. It's impossible, right? I can do a zigzag, but I can't do a straight line. So collinear means meaning together, linear meaning line, together on the same line. I put you on a timeout, shame, for spamming with your little things. So sorry about that. Um, Objects such as points and lines are considered coplanar if they're on the same plane. So objects such as points and lines are considered coplanar if they're together on the same plane. So you can have multiple planes. So here's a plane, and all of these objects are on it. But I can have another plane, and there can be objects on that one, right? Geometry is very much about three-dimensional space. We're imagining, right? I can have, do I have, here's a plane, here's a plane, and here's a plane, right? These are separate planes. There's points that are on this object. There are points that are on this object, right? So coplanar means they all are on the same plane. If the points are on separate planes, they're not coplanar. I'm trying to do something here with the chat. I like lost the chat on my screen. How do I? I don't know. All right, whatever. Moving on. Sorry. So the homework's going to be pretty straightforward when it comes to naming things. I literally, why isn't the chat updating? It's honestly kind of frustrating right now. Um, there we go. There we go. There we go. I got it. Robo Janitor Neo says, "Dude, Mr. Beast is watching your stream. Why do I doubt that?" Okay, so the assignment that we're gonna do in class is pretty straightforward. Initially, we're just gonna be naming objects. So here's some examples of some problems. Example A: name an example of each of the following. So what is a point? Here's this picture. What is a point that's on this plane? Name a point. Well, point R, right? That's one point. What's another point? Point N. So those things are points, right? I'm not blowing your mind here, right? I highly doubt I'm blowing your mind. So those two things are points. And if you connect those points together, you end up with a line. We need to be really particular about how we're labeling these things, right? A line is something that is infinite, so it has the double line over the top, right? The double arrow, sorry. I can name that another way, right? I could name that NR. RN and NR are the same thing. Homework in quotes. Classwork. We're going to do it in class. Or the third way that we can name it, I'm a seventh grader. I don't know what you're talking about. Are you actually? Are you a stranger turning into the chat? Or we could simply call it line L, right? Lines can be referred to by a single letter if that makes life easier. In this case, we're calling it line L. The plane is being referred to as plane M, right? That's where all of these objects exist. They exist on the plane. Well, Buddha man, you're in for a treat. Um, a segment is something that has a clear beginning and end. So ignore those arrows that are going off in infinite directions. What if we just refer to the middle part, NR, and I'm going to put a bar over the top? It's no longer, let me clean that up a little bit. It's no longer the double arrows, it's just a single bar. I'm referring to a segment, or I could call it RN. Either way, we're good. Why is it that we can't divide by 0? because you can't split something 0 ways. Try to give your one apple to 0 people. Someone has to have it. Either you do or they do. No one. You have to split it somehow. Can't divide by 0. You live in Alabama. What? Dang. Welcome to the stream, Buddha man from Alabama. A ray is something that goes off in one infinite direction. So I could refer to NR, which here, there's 40 people watching right now. Answer this in the chat for me. Which one is NR? This ray or this ray? The orange or red? Which one is ray NR? The orange ray or the red ray? Orange, orange, orange. A few more people want to type orange for me because they're right. Yeah, NR. It starts with the letter N and goes towards the letter R. That's ray NR. But when you start at letter R, or point R, I should say, and go towards point N, that's ray RN. And the naming rules are all over here. You should really need to take these to heart. All right, you really need to soak these in. A single letter represents a point. 2 letters is either a line or a segment, depending on what's over the top of it, right? 2 letters with a single arrow, that's a ray. Hey, let's freaking go, guys. We got the orange. Okay, so that is that example. Let's draw the following. ML is a ray. Tell me, once again, asking a similar question. What letter should I start with? M or L? All right, I'm going to start with M. I didn't wait because I just wanted to draw it. There's M, there's L, and it's going infinitely in the direction of L. We're starting at M but going off towards L. Yes, thank you for typing M. I appreciate it. The questions are going to be this easy on the classwork tomorrow. Okay? So we're going to get done with class super quick, or B-Day. I know we have a mixture of people watching. RT intercepting. Intercepting is just another fancy word for intersecting. So RT and AB, are those segments or lines? If you want to message in the chat, are RT and AB segments or lines? Here's R and here's T. Here's A and here's B. Is anyone going to message in the chat the answer to that question? Are RT and AB segments or lines? Well, I guess I'll answer it for us. That is segment RT and AB. How do I know they're segments? Because they don't have the arrows over the top. Okay? The arrows makes them lines. Okay? No arrows, it's a segment. And they're intersecting at point Q. So again, segment is a finite distance, a clear beginning and end. A line is infinite. How do we know it's a line versus segment? When it comes to looking at the label, a bar over the top is a segment. The double arrows is a line. I really want to see and learn your high quality Valorant streams. A line that contains point B between A and C. So a line meaning it's infinite. A line that contains point B between A and C. That's pretty easy to draw. As a founder, I have been learning. Beast mode. No, I don't have any senior classes. Okay. So, by the way, let's spend a second here. What could we call this? This is line AB. I could also call that line BC. I could also call that line AC. Those are all three of those are an appropriate name for this, right? It doesn't matter what two letters you choose on that line because it's infinite. Whether I'm talking about this or whether I'm talking about this, right? It's infinitely, it includes all of them. It doesn't matter what two letters you choose. The fact is, you're going to get that entire line because it's infinite. You would not refer to this as line ABC. Okay, that's wrong. Darius, right? Beast mode. I always I forget the nicknames, the usernames, but you're Darius, right? Um, can you do CA? Yeah, CA would also be good. Figures in geometry are made of points, lines, and planes. Use the model of three intersecting planes to answer the questions below. What is the intersection of two lines? When two lines come together, let me go into this one so you can see my arms waving around. When two lines come together, what are my two arms intersecting at? They're intersecting at a single spot. You might refer to that as a point. So they intersect at a single point. What is the intersection of two planes? Well, I don't. I usually have this example. Okay, look at a corner in your bedroom right now or your living room. Right, you have two walls that are coming together. You could run your finger down the seam of those two walls. Each of those walls represents a plane, right? It's a flat surface. And when those two flat surfaces come together, you can drag your finger down the intersection and you might refer to that as a line, right? It's got no beginning or end. It's infinite. I understand that your walls end, but planes are I'm looking at my screen, not at the camera, but planes are infinite. So you could drag your finger all along that. So the intersection of two planes is a line. I hope that made sense. What is the intersection of three planes? Well, you can see these one, two, three planes coming together. They're coming together at that single point. What is formed when two opposite rays share an endpoint? Here's a ray going off in that direction, and then they share and they go in opposite directions. Well, all of a sudden you've created a line, have you not? Right? These two rays going in opposite directions in the end just create a single line. Oh, my bad. Algebra 2 is starting very shortly. How's the quality of the stream, by the way? Is anybody getting any buffer issues or dropped frames or anything like that? It's good. Okay, great. Awesome. Wait. That makes me feel good. Um so I hope those are good. We're about to wrap this up and be ready for Algebra 2. Again, I'm just kind of thinking out loud, but just we're all going to be in class tomorrow / B day. We can hit a few things before class, then we're going to do our breakout rooms and we're going to do the classwork. And the classwork is going to be problems like this, right? Is this a point? Is this a line? Is this a ray? Is this a segment? that sort of thing, right? Just do you have a good grasp on all these terms? Something about learning math here on Twitch makes me feel safe and stressed out. I'm glad to hear that. I love this. I think this is great. I'm glad. I appreciate your guys' turnout. Um, for the statements below, so last few things here, this is the very last page. If you're following along with your own notes, you're great. I love you. You're fantastic. If you're just watching, try to take notes next time. I understand. Like, I mean, it might be easy this first lesson, but like, trust me, you're gonna want to take some notes at some point. For the statements below, decide whether the situations are possible or impossible. For any situation you think is possible, give an example. Hannah asks, "Do we turn this in?" No. These are your notes. What you're turning in is the work that we do in class tomorrow. That's what's for a grade. If you ever want me to look at your notes or ask questions, I'm more than willing to. But no, we don't need to turn in these notes. Are there any other ways I can take notes? What do you mean? You're not in this class. Are you? You're not? Come on, Robo Janitor. What do you mean? But what do you mean? Is there another way to take notes? All right, here we go. A line and a plane can all have points in common. A line and a plane can have all points in common. Here's a line. Like, the best way to think of these through is like, can you think of a situation, right? Here's a plane, and here's a line on that plane. The plane clearly has way more points on it than the line, right? There's only a few points, in quotes, on the line, but there are so many other ones on the plane. So this is impossible. Um, 14. A line and a plane can have exactly 1 point in common. I like to do this with physical objects, but I can't exactly do that. But imagine here's this piece of paper, which is like a booklet for my Google Home that I got. Imagine if I just stabbed it, right? Boom. This marker is going to go through the piece of paper at one single point, right? I can stab a plane. I can do my best to try to make a drawing. Right? That line is going through the plane and stabbing it once. It is indeed possible. You were kidding. Okay. A line and a plane can have exactly 2 points in common. Well, look at my drawing over here for number 14. That line can't physically wrap back around, right? That line can't physically wrap back around and then hit the plane again, right? It has to go straight through once, and that's it. It can't physically wrap itself back around because then that's not a line anymore. So this is impossible. The Buddha man. Time travel? What's that? A line and a plane can have no points in common. Sure. Here's a plane down here, and then here's a line up above it. Right? This is a three-dimensional world that we live in. Right? This is a three-dimensional world that we live in. Not everything has to exist on one flat surface. You can have some things down here and some things up here. Two collinear points are also coplanar points. That one's. Are you going to save the whole video after? Yes. Two collinear points are also coplanar points. That one's kind of hard to imagine, but it is true. Okay, that is possible. But here's 2 points that are on the same line, right? They're collinear. Well, that line has to exist on a plane. It has to. Everything exists on a plane. And I'll refer you back up to this image on 16. Yeah, that line doesn't exist on the purple plane, but it exists on the orange plane, right? I might be kind of bent. I might be kind of blowing your mind when it comes to imagining these things, but um, nonetheless, it is true. The more you kind of manipulate these things, the more you start to realize that. The more you start to think in 3D. There can be more than one plane connecting any 2 points. There can be more than one plane connecting any 2 points. The answer, if I have, I'm trying to imagine that myself. Yes, there will be a VOD. So if I have this point and this point, I would say, oh, this is so hard to draw. Like, imagine this plane, and so this is extending forever, right? Off into the distance. But I can have another plane that, like, crosses through this way, right? Oh, that's a terrible drawing. That's too hard to draw. I'll see if I can find a good diagram for class tomorrow. The answer is yes. I'll see if I can find a good one online. I don't have one handy at the moment, but I'll try to see if I can find a good one online, and I'll show you next class. Dropping my pencil. And we literally did it. We did the notes. That was super quick and to the point. It lasted a little longer because I'm answering questions and distracted by chat. But uh, yeah, I don't have too much more to say. I'll probably ask a few questions via Socrative to see who watched the stream and see what we need to get help on. The replay will be available. Tell your friends in class who didn't make it that they should watch the Twitch stream next time, but tell them to watch the replay. We all need to watch this, and then we'll be ready for class. Can you go back to the first page? Sure thing. No problem. I can easily understand this because I'm an actual professional Minecraft player. All right. If you're here for Algebra 2, would you mind messaging in the chat saying I'm here for Algebra 2? Or just type Alg 2, Alg 2, Alg 2. If you're Geo and you just want to stick around, that's totally cool. But if you're here for Algebra 2, would you mind typing Alg 2? After Algebra, do you think you'll be streaming Valorant? I might play something for fun. Maybe. I'm here for Algebra Dose. Should I make another announcement? Or is that overkill? I said live on Twitch in just a few. Because only, I mean, not to waste your time, those. I mean, I guess 6 people are watching and everybody else can just watch the VOD. So we'll just get started. That's fine, I guess. Let me. I have the notes pre-filled out just so I don't screw anything up. So let me pull those up real quick. Give me like 30 seconds to pull up the notes that way. I just don't want to screw anything up while we do the notes. I just like to make sure I. Not to say I don't know how to do math. I just like to have it as a backup. You know what I'm saying. You know what I'm saying. Oh wait, we changed the notes this year. Crap, that's right. It's like a combat. Okay, I won't screw anything up. I believe in myself. Okay, here we go. All right. So, Algebra 2, Algebra Dos. Here we go. Functions, notation, domain, range, evaluation. That's the title of our notes here. So, a linear inequality. We have all these different types of interval notation. A linear inequality. I just wish, because I have like a really good definition for linear equality. So, a linear inequality is an expression with one or two numbers that uses a bracket or a parenthesis or a bracket and or let me scratch that. See, that uses a greater than or equal to, less than or equal to symbol. Thank you for believing in me. Um, so an expression with one or two numbers that uses greater than or equal to, less than or equal to. Inequality. Inequality meaning not equal, unequal. So, oftentimes we use inequality notation for representing domain and range, which is also in these notes. But it's an inequality just represents an interval of numbers, right? Like from 3 to infinity, right? That's a long range of numbers from 3 to infinity, or maybe a small range of numbers from 2 to 5, right? Sometimes the answer is not just a single number, it's a whole range of values, right? So we have to be able to describe that range of values using some unique symbols. So this interval notation here, using parentheses and brackets, what does that represent? Well, what that is saying is I'm out of I'm burning myself out. I'm confusing myself. I'm speaking too many words. I need to get in the groove. Getting in the groove. It's been a minute since I taught. Right? Long summer. Um, what does this mean? It means everything from negative infinity all the way up until 7. But what's the deal with these parentheses and brackets? I'm going to try to cram and make room here. A parenthesis means not included, and a bracket means included. Right? So what do I mean by that? Right? To include means it's part of your answer. I want to include that as part of my answer. To not include it means, well, it's not a part of the answer, right? So I use a parenthesis, right? You must be, right, 10 years or older. So that means it includes 10, right? You have to be older than 10. Well, that means you can't be 10. You must be 11 or older, right? So about inclusion or not inclusion. So convert this interval notation to inequality notation. Everything from negative infinity to 7. So all those negatives are less than 7. So I say less than 7. But the bracket means included. So how do you say included when it comes to an inequality notation? You use the equals than sign. Let's jump and look at C. Everything from -2 to infinity. That means the numbers are getting bigger and bigger and bigger as we go off to infinity. So everything bigger than -2, meaning greater than -2. But because it's a parenthesis, it's not included, so we don't use an equal sign. When something is trapped between -3 and 7, we put the variable in the middle and we say, okay, it's less than 7, but greater than -3. And because there's brackets, we're using an equal symbol. It feels like we're not doing anything here. I'm just converting notation. I'm not really doing any math. I'm just converting the notation. It just represents a range of values. So what about that? -8 to, or negative infinity to -8 union. If you see a union symbol, it means we use the word or. So that means from negative infinity to -8 means all the numbers that are less than -8. Or if we're going from 6 to infinity, that means all the numbers that are bigger than 6. Let's go the other way around. Convert your inequality notation to interval notation. X is greater than or equal to -9. That means everything bigger than -9. So I'm going to start at -9. It's an equal sign, so I'm using a bracket. And then to be greater than -9 means to get big, so I'm going to infinity. I have a poor time phrasing this. If you're saying that you're confused, this notation just represents a range of values. It's not a single number, it's a group of numbers, right? So maybe if I restart on one of these examples, if I draw the picture, here's negative infinity clear over here, and here's 7, okay? Actually, let me erase that. And there's 7. A bracket means included, so I'm going to use a filled in circle. So everything from 7 clear to, that's a range of values, okay? I know that range of values, this seems random, that's because it is, but it's this big group of numbers. So we can write from negative infinity to 7, that represents that large group of numbers, or another way to phrase that is all of the numbers that are tinier than 7. In other words, all the numbers that are less than 7. So it's just another way of describing the group of numbers. And when you see the bracket, that means the number is included. And when you see a parenthesis, that means it's not included. And when I say not included and included, right, it's a part of your solution or not a part of your solution. If I asked you a very simple question, what numbers are bigger than 2, right? You would say, well, 3 to infinity, right? Well, isn't 2.1 bigger than 2, right? Everything except for 2 is bigger than 2 as far as when you get bigger. So that would be from 2 to infinity. But I'm not including 2, right? That's a parenthesis. But 2.1, 2.2, 2.3, everything all the way out into infinity is included. So the parenthesis just means to exclude, whereas a bracket means to include. Let's convert another one. What is this saying? X is less than -1. That means it is smaller than -1. It's not equal to -1. It's less than -1. So we're using a parenthesis on the -1. And when we get smaller, that means we're going towards negative infinity. You always write your parentheses from small to big, right? We read from left to right. The numbers go from small to big. So everything from negative infinity to -1. This or word means union. So everything less than or equal to 4. So what numbers are less than 4? 3, 2, 1, all the way out to negative infinity. So negative infinity all the way up until 4. Because of the equal sign, I'm including it. Or means union. And then everything bigger than 11. So I'm going clear out to infinity. Think like brackets are equal sign. Exactly. Let's skip to domain and range. Maybe I should have done that first and kind of ignored the notation. Let's have a use case. Does anybody remember what domain is? Because you learned it in Algebra 1. Does anyone remember what values are the domain values? Those of us who are watching. Anybody remember what the domain value is? You're gonna leave me hanging? That's the x values of a function. And the range is the y values. Another word for domain is input. And another word for range is output. So, um, you input in. So, what does a function do? It performs a task, right? You plug in a number and it spits out another number. You plug in the x value and it spits out the y value, right? A function performs a task for you, right? A function gets a number put into it and a number gets spit out of it. Okay, and that's how our graph appears, right? We have an xy coordinate plane, right? Because there's x and y values. So the domain is the x values and the range is the y values. So when someone asks you what is the domain and range, the domain and range is not a single number. It's a large group of numbers. It's an interval of numbers. You have to use that interval notation. You have to use the inequality notation to describe it. It's not a single number. So that's why we need that notation that we were just using. So let's think about this. What's the smallest this graph can go, right? It's bobbing. This graph is bobbing up and down, right? This graph is bobbing up and down, but the highest it gets is up here at 1, 5, 6, 7, at 8, and the lowest it gets is at 0. You see that? So the y values go all the way up to 8 or all the way down to 0. That's a group of numbers. Does it include 0? Yes, it's touching it. Does it include 8? Yes, it's touching it. So one might say the range is from 0 to 8. And that's why I need that notation. And I used a bracket because 0 is included. And I used a bracket because 8 is included. What is the domain? The domain is the x values. This function is infinitely traveling, right? It's going forever to the right and forever to the left. Is it ever gonna stop? Right? This is going on forever. Is it ever gonna stop? The answer to that is no. So we actually refer to this domain as all reals. Or you could write it as negative infinity to infinity. It doesn't have a beginning or end. It just goes from forever over here to forever over there. It never stops. So that's why we like that notation. That's the point of this notation. Let's do another domain and range. This line, a very simple line, it's going forever up and forever down. And at the same time as it goes forever up, it's also going to the right, is it not? Right? It's slightly traveling to the right. My webcam's flipped. Is that the right? It's slightly going to the right. And as it goes down, it's slightly going to the left. So it's going forever up and forever down. So the range, the y values, is all reals. And as it goes forever to the right, webcam's flipped. As it goes forever to the right and forever to the left, it's going to hit all reals for your x values. So that is all reals. I think domain and range is better understood when you have a picture that has limitations. So again, when I'm talking about domain and range is the y values and domain is the x values. Okay? So what are the x values of this ellipse, this oval? What's the furthest to the left it can go? Right there at -7. It's not going any further to the left. It's stopping at -7. And what's happening over here on the right? The furthest it's going is +7. So when it comes to the domain, the smallest it gets is -7, and the biggest it gets is +7. So we would describe that as -7 to 7. It clearly touches -7. It clearly touches +7. So I used a bracket to say included. And then the range. How high up is this ellipse getting? It's touching at 1. And how low is this ellipse getting? It's touching at -9. So it's clearly touching at -1, and it's clearly touching at -9. So our range is from -1 to -9. And I used brackets to say that it's included because it's touching it. Is that starting to feel like that makes sense? Those of you who are watching, if you want to chime in the chat, do you understand the use for that? Oh, you're right. No negative. Do you guys understand what we're getting at here? Are you feeling a little more comfortable with that? Yes, yes. Robo still in the chat. Okay, cool. So I know a few of you were like, I'm confused. I don't know what's happening. I get it. It's just random, right? These groups are just random, but just know we're just converting, right? Yeah, I know the iPad's about to die. It'll make it. Why am I less confusing? Are you not in my class? That's cool. Thanks for showing up. Um, so let's look at number lines though. Turn off is slow chat on. Oh, how do I turn that off? Slow mode. Off. Is it off now? Yeah, it is. Okay. Thanks for pointing that out. Um, okay. So let's look at a number line, right? A number line expresses that range, right? So how can we visualize this interval? We are including 6 and it goes all the way off to -infinity. It's that simple, right? That's the visualization, right? That's a long strand of numbers. We're saying from 6 clear on out to infinity. Here's an inequality. What are we saying? It's trapped between these two numbers. The equal sign means include, so I'm going to have a filled in dot for the -1, but then it's less than 6, but not equal to 6, so I'm going to have an open circle on the 6. So that's a smaller group of numbers, but still a range nonetheless. From 2 to infinity. So the parenthesis means not include, so I'm going to use an open circle to say, well, it's starting at 2, but it's not actually including 2. And then it's going from 2 clear out to infinity. When it goes off to infinity, there's no end, it's just an arrow. Write the inequality for the given graph in interval notation? Is there a way, can we go the other way around? So let's write it in both interval and inequality, because why not? Okay. So interval meaning the parentheses and brackets, inequality meaning the less than and greater than. So where are we starting at? -2, right? So I'm including -2 and going off clear to negative infinity. Boom. I'm using a bracket because it's included. How would I express this as an inequality? Those numbers are getting smaller. In other words, less. So less than -2, but I'm including the -2, so less than or equal to. This inequality's been split in half. Whenever you see that split in half, you're using the union symbol. Okay? So what's happening there? We're going from negative, and let me switch up colors just for funsies. We're clear out at negative infinity, and we're ending at 2. So negative infinity all the way to 2, but that open circle means we're not including it, so I'm using the parenthesis, and then union that together. What the? How did I just do that? And then union that together with where are we starting at 6 and going off into infinity. With our inequalities, we would write something like this. We're less than 2 or we're greater than, whoops, I need to write x though, or we're greater than 6. Wait, why do we use parentheses with the 2? On this one right here, because it's an open circle, that means the open circle is telling me that, oh, that is not included. So a parenthesis means not included. The filled in circle at 6 means that is a part of the solution, so I use a bracket to signify that, hey, this is included. Okay. I don't want to like take up too much of our time. I don't want the stream to be something that's long and you avoid. So I'm not going to do every example. But I think we got a lot there when it comes to the domain and the notation. You can always watch this back if you want to hear my wording a little bit better at some point. But the one other thing, which it looks like there's a lot of examples, but again, I don't need to hit all of them, is evaluating. And evaluating is just a fancy word for plug in the number. That's all that means. Just plug it in. Plug and chug, as they say. So just plug in the number, right? Pull out your calculator, right? Pull out your phone. Let me see if I can get. Can I? Oh, I should have downloaded a calculator app on my iPad. Well, I'll just write it down. So when I say plug it in, that means literally, carefully plug it into the function that you see above. It's as easy as that. Just plug in the number. Desmos is your friend. Use Desmos. Oh, I should do that. I should pull up Desmos. Give me like a hot second. Desmos. Desmos calculate. Um, how do I happening here? What's happening here? There we go. Okay. My camera's in like a different spot now. Okay. So here's my calculator. Let me switch back. So when I plug in 2, again, I don't really, you probably could do this in your head. Maybe I should do this one in my head. 2 minus 4 is negative 2. Take the absolute value of negative 2. What is that? Positive 2. 2 times 2 plus 5, which is 9. You can plug that into your Desmos, into the Desmos scientific calculator. I can do 2 times the absolute value of negative, or not negative, just 2, of 2 minus 4, close the absolute value, plus 5. Boom, it tells me 9. So if you don't trust yourself, you can go plug it into a calculator. But let's do another one. G of negative 3. It literally just means plug it in. So negative 2 times negative 3 squared minus negative 3 plus 5. When you do the assignment in class, you're gonna need a scratch sheet of paper to do this. I don't think that we're all able. It's probably way more time consuming to plug it into a calculator. I'm not even gonna lie, and you just you got to be careful about how you plug it in, whether you write it down or whether you do it in a calculator. See how I obsessively used these parentheses where I was plugging in for x? Right? It's just keeping myself organized. So when I square negative 3, I get 9. And when I do minus negative 3, I get plus 3. So 9 times negative 2 is negative 18. And 3 plus 5 is 8. So I end up with negative 10. I'm literally just plugging it in. That's all the word evaluating means. Let's spice it up here. Let's do this one here. G of negative 2. I'm going to erase this so that way I have room to write. G of negative 2. So negative 2 times negative 2 squared minus negative 2 plus 5. Let's do that part first. So I get negative 2 times 4 plus 2 plus 5, which is negative 8 plus 7, which is negative 1. But then f of 0, what's that? 2 times the absolute value of 0 minus 4 plus 5. So that's 2 times the absolute value of negative 4. The absolute value of negative 4 is 4. 2 times 4 is 8. 8 plus 5 is 13. So negative 1 times 13, right? Remember, I'm taking the g times the f. So negative 1 times 13 is negative 13. Well, it's still going to be on the screen. I'll do the next one a little slower. We have g of 6 and f of 6. Let's do g of 6 first. This will be my last one that I do of these because they get repetitive. G of 6. When I plug in 6, I get negative 2 times 6 squared is 36. When I subtract 6, I get negative 6. 36 times 2 is negative 72. Negative 6 plus 5 is negative 1. And negative 72 minus 1 is negative 73. That's g of 6. That's the first part. What's f of 6? 2 times 6 minus 4 plus 5. So the absolute, so 6 minus, I'm going to do a little in my head here because I'm running out of room. 6 minus 4 is 2. The absolute value of 2 is 2. So 2 times 2 is 4. Again, I'll say that out loud. 6 minus 4 is 2. The absolute value of 2 is just 2. 2 times 2 is 4. And then 4 plus 5 is 9. So in the end, what are we doing? G of 6, which is negative 73, minus 9, which is negative 82. All right. Last bit. Let's look at this one. I like these. This is similar too. Well, we can do these super quickly, actually, as extra practice. Let's do the F ones. So when you look at a function, again, what does a function do? You plug. Where are all these numbers coming from? Which numbers? These are just random functions that I've given you. They're just random. Yeah, this will get uploaded to YouTube. Well, the replay will be on Twitch too, but yeah. Like we're just practicing plugging numbers into a function. Slow towner, if that's what you're getting at. Will the filled notes be in Canvas? I'd like to encourage people to watch the video, so I'm not going to post them right away. Is it okay if I clip a few moments? Sure. So what are we doing here? You plug in a number and it spits out a value, right? You plug in a number and it spits out a value, right? So you plot those values on a graph, right? You plot them on a graph. So when you plug in 3, where is the y value? Right there. So if this is function f, when you plug in 3, what number gets spit out? 2, because that's the point, 3, comma, 2. When you plug in 3, it spits out 2. That's how a function behaves, right? How do you think a graph comes about, right? It's all dependent upon the function, right? You plug in a number, it spits out a number, and you plot those points. I plug in 3, it spits out 2. I plug in -2, it spits out 1, 2, 3, 4, 5, 6, 7, 8. -8. That's how functions work. You plug in an x value, and it tells you the y value. I'll just go ahead and do G as well. Where's 3 on here? 1, 2, 3. Right there at 3, it's at 0. So you plug in 3, you get 0. What about 6? 5, 6. Well, when I plug in 6, where's my graph? Clear up here at 0.6, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I plug in 6, it spits out 10. So here's a fun one, f of 6 plus g of -6. So where's 6 on the f graph? Here's 6 down here, and where's the point? 1, 2, 3, 4, 5, 6, 7, 8. 6, comma 8. So when I plug in 6, it spits out 8. And what about on the g function? 1, 2, 3, 4, 5, -6. When I plug in -6, it spits out -2. So 8 plus -2 is 6. I'll try to go slower. I just start rambling. I'm not trying to go fast, like too fast. I can make it a point to slow down. These are more of the same type of example. So let me switch up colors for fun. So there are four different functions here. There's the h function, the p function, the f function, and the g function. They're all different types, right? These are both graphs. This is what's called a piecewise defined function, and this is just a table of values. You might remember the good old classic Algebra 1 days where you'd make a table of values that looks something like this, right? You'd have a line, and you'd be like, okay, I'm going to plug in 1. 2 times 2 is 4, or 2 times 1 is 2, minus 1 is 1. Plug in 2. 2 times 2 is 4, minus 1 is 3. You plug in 3. 2 times 3 is 6. 6 minus... Do you remember doing that? That's just a good old classic table of values. That's all this is. So, what does that mean? When you plug in negative 2, it spits out 10. Right there it is. Where's another easy one? Is F on here again? No, we only gave you one easy one, I guess. Where's H? It's right here. So where's negative 2? Negative 1, negative 2. So again, a function, you plug in x, it spits out y. So this coordinate right here is negative 2, comma, 1, 2, 3, negative 3. So when you plug in negative 2, it spits out negative 3 apparently. See ya. And here's the p function, p of negative 2. Here's negative 2. Where does the function exist? There's the open circle and there's the closed circle. That's where the function exists at negative 2, right? Open circle means it's not included. So here's the point, negative 2, comma, 1, 2, 1, 2, 3, 4, negative 4. So when you plug in negative 2, you get negative 4. Um, I could just do a few more of these. Here's one. Let's do one that includes the piecewise function. And let's do this one. We'll go ahead and make this the last one. I feel like this gets repetitive, and we can do a few in class together. So h of 3. H is this function. So what happens when we plug in 3? 1, 2, 3. There's the point. 3, comma 2. So when you plug in 3, you get 2. Plus g of 8. That's the piecewise function. So a piecewise function, hence the name a little bit, is split into several pieces. Okay? So what happens when you plug in 8? If the number that you're plugging in is less than 0, your answer is immediately 7, but that's not our situation. If the number is between 0 and 5, you plug it into this. We're plugging in 8, which is greater than 5. So that means we're plugging it into this function. It's split into several pieces. It does one thing here, and then something else here, and then something else at the end. It's got 3 separate chunks. So negative 3, I'm going to just do this separately. Negative 3 times 8 squared. Well, that's negative 3 times 64. That's kind of a big number. 64. I'm using the calculator. Should I share that screen? 64 times negative 3 is negative 192. I was only joking myself when I believe I'd understand. You can understand. We're all just... I don't want anyone to stress. We're all in a funk. It's been a while since we've done math. All of a sudden, it'll just come flowing back. Trust me. So 2 plus negative 192 is negative 190. Should we stop there? Should we call it there? We've been on the Algebra 2 stuff for 35 minutes now. We have quite a few of you still watching me right now. Does anyone want to ask a question? I'm going to leave this time up to you. You're the one that's still here. If you want me to do something, I'm more than willing to do it. Can you re-explain the graphs at the top? Like this right here, what I'm looking at right here, like the f of x and g of x. Or this right here. So example 6 or example, there's so many f and g's. So let me, example 6, example 7, or example 8. Example 8. Okay. So let's do another one with g. So here's g of 0, just straight up g of 0. The piecewise function has 3 separate chunks to it, okay? When you plug in 0, which chunk are we talking about? This is for the chunk that's less than 0. Is 0 less than 0? No, it's equal to 0. So we wouldn't plug it in. We wouldn't plug it into this one, okay? What about this one? Well, that says when x is equal to 0. That's what that symbol means right there, equals. So because x is equal to 0, I'm going to plug it in to this function right there. So negative 2 times 0 plus 1. Well, that just cancels out. So the answer is 1. I'm not going to give you my Discord. Example D. Okay, we can look at that one. Well, G is, or X is, we're plugging in negative 2 into X. Which one is that going to go into? Negative 2 is less than 0, is it not? So that means immediately the answer is just 7. Right? If you type into a graphing calculator the number 7, or I should say y equals 7, you just get a flat line, right? It's just a constant answer of 7. That's what that's saying, right? It's just a flat line at 7. So the number's not fluctuating. That's all we're getting at there. And to look at f again, f is a table of values. What does a table of values tell us, right? This table of values is horizontal. When I learned table of values when I was in high school, they did it vertically, right? You plug in 1 and it spits out the answer. You plug in 2 and it spits out the answer. You plug in 3, it spits out the answer. So when I look at this, that's, again, what does the word evaluate mean? To plug it in and see what answer you get. So what this is when you plug in the number 1, I don't know what function. I don't know what this looks like. I don't know what that function looks like. It's just a table to me, right? But all I know is that when I plug in the number 1, it spits out the answer 22. When I plug in 2, it spits out the answer 26. That's all I know. What's up, Blaze Buster? Why would it just be 7? Because that's what it's telling us. That's, I mean, really, that's all I can say. It's telling us that the answer is simply 7. That it's just the way it is. Um I mean, I know that is like I don't understand, like what do you it's just a random function. I can graph this real quick if you want to see that. Give me a second. So if you look at this, so I'll move my webcam. You can see I typed in the three functions, right? So the piecewise function is split up into three chunks. If you plug in the number 0, if you plug in anything less than 0, it's a flat line at 7. The second you plug a number in between 0 and 5, you're going to get one of these values. And the second you plug in the number 5 or bigger, it's all of a sudden clear down here. So that's what this piecewise function is. It's got three chunks. This flat chunk at 7, this little line here, and then this thing that goes clear down here. Can you do example 1 and how to figure out if it's greater than or less than? So it's greater than if the numbers are getting bigger. It's less than if the numbers are getting smaller. I can start from scratch on these. So when I look at this, negative infinity all the way up until 7. So in other words, everything smaller than 7. Everything less than 7. Because the numbers are getting smaller to negative infinity. But it's a bracket, so it's less than or equal to, because bracket means included. And if you want to include something, that means it's equal. This is saying the numbers between negative 3 and 7. Or, in other words, everything bigger than negative 3, but also less than 7, right? It can't get bigger than 7. It's got to be trapped between the two of them, right? Think of that idea of being trapped, okay? So it's bigger than negative 3, right? That's as small as it's going to get, but it's less than 7. It's trapped between those two numbers. Negative 2 to infinity, meaning everything bigger than negative 2 is just getting really, really big. So it's greater than negative 2. And then this whole union thing means this or this. So what does this side say? All the numbers that are getting really tiny, right? Negative infinity, all the way up until negative 8. So everything less than negative 8, because we're getting smaller. We're getting really negative. Or 6 to infinity, meaning everything's getting really big. Everything's bigger than 6. And because of the bracket, we're including it, so it's greater than or equal to. Thank you for coming. Okay, does anyone else have any questions? I kind of need to end the stream to produce the replay. I didn't really think of that. If I don't end the stream, there's no replay. So I need to do that. But does anyone have any questions before we call it? The rest of you that are here? X and infinity just the same. X represents the number, right? So this is referring to a group of numbers. So X represents that group. It's saying X, the numbers that I'm talking about, are bigger than negative 2, right? Here's this group of numbers, negative 3 to 7. So X, the numbers that I'm talking about, the group that I'm talking about, that group of numbers is between 7 and negative 3. So X represents the numbers. And that's saying, okay, the numbers are trapped between these two things. The numbers are bigger than this. Does that logic make sense? All right. So I am going to end the stream here. I might hop back on. I know there were some people counting on me playing some video games. I might hop back on. I didn't make any promises, but I do need to eat dinner and stuff like that. I need to end the stream to produce the replay, all that jazz. So there's a little bit of back end work for me to do. So, um, thank you for coming. I will. I'll maybe try to hop on. No promises. Okay, but I got to end it. So thank you for watching. Might better than a no.